Hello, my name is Juan Carlos Nogueira. I'm going to present an analysis on the supplements department of Wedge CO-OP. This diagram represents the description of the process we are going to follow. The first part consists in taking the data from the supplements department, doing the EDA, and transforming it into historical data. After data has been pre-processed, we can go into the RFM segmentation, and from that we can derive which are the target customers we need to focus on. Having done the RFM segmentation, we can derive some business rules, and the data is applied to three machine learning algorithms: a tree, k-means, and k-medoids. Finally, after having identify the target customers, we can derive some insights and strategies for the marketing department. Well, what is the problem we're trying to solve here? This control chart has in the horizontal axis the years and in the vertical axis the mean spend of the customers of the supplement department. We can see that over the years the supplements department has experienced a drop in the spend of their customers year by year. In the blue zone, we have the normal zone, that this is plus minus 1 standard deviation from the means. In blue are the normal points, in orange the borderline ones, and in red the critical or abnormal ones. But what will happen in 2016? 2016 experienced a fall of 51% from the values of 2015. In this case, we have only 2 months, January and February, so the means is calculated over 2 months only. So the problem is that the customers of the supplements department have been dropping off their spend during those years. Hence, it is necessary to take some marketing actions immediately to recover from that issue. This histogram of the spend in a log scale shows that we have very few customers with large amounts of spend, and the majority of the customers spend less than $500, which is the red line. In short, the supplements department has few customers with very large spend, and most part of the customers spend very little money. Okay, now we have already the data prepared and we know what is going on in the department. So we are going to proceed to our RFM segmentation. Now we are going to talk about the RFM classification. Why are we using RFM in this analysis? There are various reasons. First, it is a classical marketing tool, so it is aligned with the mindset of the executives that are going to read our report. Second, RFM is a classification method per se. And third, because from the RFM classification it is easy to derive some business rules and also to mark the observations in order to pass that for the machine learning classification methods. The RFM segmentation found 11 classes that are presented in this bar chart. From top to the bottom, they are ordered in terms of fidelity to the company. So we have champions, loyal, potential loyals, promising, recent, customers who need attention, customers about to sleep, customers at risk, customers we cannot lose, customers hibernating, and lost. As you know, RFM stands for recency, frequency, and monetary. In this heat map, we have in 2 dimensions the plotting of the third dimension, that is monetary. In the horizontal axis are the frequencies, in the vertical the recencies, and the different shades of blue represents the amount of money. we need to find where are the target customers here. We found two niches. The first one are good customers with drop-off not explained by low recency. The other niche are good customers with drop-off explained by low recency. The target revenue of those customers during the period 2015-16 is more than $400,000, and the number of target customers are 2,173, which is approximately 24% of the total customers. RFM classification is not good enough because we found a very diverse kind of target customers. So we decided to conduct a second classification to better understand the characteristics of those customers. This second classification is based on the quantiles of the spend of the customers. We found three classes: the VIP, which are the 99th quantile, those are 23 customers; the important ones that are represented by the 95th quantile, and those are 93 customers; and the normal, those are the rest of the customers, and those are 2057. Having conducted the RFM segmentation and a second classification by the spend, now we are going to proceed to define business rule that could be practical for the marketing department. Our first business rule is a generic target business rule and consists in contacting every customer complying with all three conditions. First, last purchase was more than 62 days ago, that is almost 2 months ago. Second, the total spend in the last 14 months is greater than $42. And third, the number of purchases in the last 14 months is greater than 2. On the bottom, we have the formal way to express that in a mathematical way. This business rule can be easily implemented by the IT department using SQL queries. A second business rule can target the VIP customers. This rule expresses that a VIP target customer comply with all three following conditions. The last purchase was more than 62 days ago, almost 2 months ago. Second, the total spend in the period is greater than $900. And third, the number of purchases in the period 2015-16 is greater than 5. A business rule to target the important customers consists in contacting all customers complying with those three conditions. Last purchase was more than 62 days ago, almost 2 months ago. Total spend in the period is between $500 and $900. And third, the number of purchases in the period is greater than 2. Finally, a fourth business rule is for normal target customers, and those comply with those three conditions. Last purchase was more than 62 days ago, almost 2 months ago. Second, the total spend in the period is greater than $42. And third, the number of purchases in the period is greater than 2. Next, we proceed with the machine learning classification. But before presenting the data to the algorithms, we had to oversample the less populated class in order to have balanced data set. In order to have a better control of the algorithms and prevent overfitting, we divided the data set in 70% for training and 30% for testing. 3 machine learning classification algorithms were implemented: a decision tree model, a k-means model, and a k-methods model. The table presents the performance metrics for the 3 models and the business rule using testing data, that is, data unknown for the models during their training process. The perfect values of the metrics for the business rule are unfair because this business rule model is extremely biased by the current data. In the context of this problem, the false negatives are much more costly than a false positive, because it's not expensive to send an email with a promotion for a customer that is not a target, but it's really costly not to pick a customer that is a target. For that reason, recall and F1 are the most appropriate metrics for this context. And in this case, the tree model outperforms all the other machine learning models. The reason for that is that k-means and k-medoids are really sensitive to extreme outliers, and this is the case of this data. This slide shows 4 jitter plots. A jitter plot is like a scatter plot, with the difference that we introduce a little bit of random noise to prevent the points to collide one with the others. We have 4 jitter plots, one for the tree, one for the business rule, one for the k-means model, and one for the k-medoids model. In those graphs, we plot true negatives as gray points, true positives as blue points, false negatives as green points, and false positives as red points. In the case of the tree, we can see that it performs really well, having only one false negative and one false positive. The business rule, not surprised, performs perfect. The k-means model doesn't perform very well because it has a lot of false negatives, which are really costly in the context of this problem. The k-medoids model performs quite well because even if it has a few false positives are not costly in the context of this problem. So far, we have already segmented our customers by RFM, by their spend, and by 3 machine learning classification models, and by business rules. So now we have a pretty good idea how those customers are, so we can infer some insights and strategic movements for the marketing department. This map shows the target customers classified in 2 dimensions, by customer class in the vertical axis and by customer RFM segment in the horizontal axis. This way, we can see how customer classes are composed. The areas of the circles correspond to the population of each group. An important insight derived from this graph is that if we observe the VIP customers and the important customers, almost all of them are champions and loyals in terms of RFM segmentation. That means that they have high recencies. Hence, we should explore other factors rather than low recency to explain the causes of their drop-off. Now we are going to explore how are our customers in terms of their spend and population. This graph plots circles with different areas according to the proportion of their population, and in the horizontal axis are the classes, and in the vertical axis the median spend. It becomes clear how massive the population of normal customers are compared with the VIPs. However, a typical VIP customer spends much more than a normal one. This map plots customer classes against total spend in thousands of dollars. By dividing the total spend in thousands of dollars by the population of each class, we arrive to the ratios presented in that table. From the table of ratios, we can see that the VIP ratio is 7.9 times the ratio of a normal one. That means that catching a VIP customer represents almost 8 times the revenue of catching a normal one. In the same vein, catching a VIP customer represents almost twice the value of catching an important one. Those insights can be used to measure the effort applied for each strategy. This map plots the classes as circles with areas in proportion of the total spend of each group. In the horizontal axis, we have the median spend in dollars, and in the vertical axis, we have the total spend of the class in thousands of dollars. We can see that VIP class produces in total $29,000, which is almost half of the total spend of the important class and almost 1/10 of the total spend of the normal class. From the graph, we can find another insight. Catching a VIP target produces more benefit than catching a normal one. However, even catching all the VIPs does not surpass the profit of the whole normal class. Consequently, we require a diverse marketing strategy to attend the three publics. A practical way to see the three classes is by using this histogram, which represents the spend in dollars for the period for the target customers. This analysis has found 2,173 target customers. However, depending on the capabilities and budget of the marketing department, this list can be reduced. In the report accompanying this analysis, you can find the list of the first 250 customers to be contacted. The red line is the $900 spend and represents almost the 99th quantile. The green line represents $500 spent and is almost the 95th quantile. So we need to have a different strategy for each of the classes of target customers. For instance, for the VIP customers, which are 23, we suggest to visit them by executives of the company, to invite them to events, dinners, to offer them really customized offers, and by personal interviews, trying to find what are their interests and reasons for diminishing their spend. In the case of the important customers, which are 93, we suggest to create customized offers and to have personal interviews seeking their interests. Finally, for the normal customers, which are 2,057, we suggest a generic marketing approach using emails, phone calls, letters, etc. Offer them discount coupons and sending them a poll seeking their interests. Finally, because we found that the reasons for the drop-off cannot be only the low recency, we would like to enhance this analysis by exploring the products purchased by customers to find patterns. Those patterns could help to identify best sellers, to identify reasons for rejection. Perhaps we need to review prices and quality, to review stock policies, to identify customers' interest by segment, to refine customers and segment preferences, to create more attractive offers, and to explore in detail the insights and findings of this analysis. Many thanks for your attention. If you have any questions, please do not hesitate in contacting me at the email shown in the slide. Thank you very much.